this is why we're here, because this stuff happens. And this is me, and I just wanted to point out that, yeah.
Not yet.
I'm kind of puzzled because I know that Lassosoft don't like me, the way they treat me, but I thought that Pre-Prog actually picked up every smart brain they had around the world, so I wondered why they didn't come to me first. It was a deep insult. When you looked at the Lasso site advertising this event, this is what it said about this seminar. As you can notice, they didn't get the word right. This is Firefox. This is how it shows up in Safari, or it's the other way around, I don't remember. This is the code. Here it is. And it happens to us a lot, right? As soon as we try to write anything that's not within APZ 0 to 9, this stuff happens. And it's kind of tragic. What we're trying to say is this. And Sean, what you see here is a shrimp sandwich. That's what this means. Shrimp sandwich. He asked me about that earlier.
What do you do with it?
Eat it.
Stupid question.
I would say that practically every roadhouse or cafe in Sweden and Denmark have shrimp sandwiches. It's very common there. It's what you eat if you don't want meat. You eat a shrimp sandwich instead. So, and the reason that we love it when we're coding is because it contains the characters that we have trouble with. So if we insert that anywhere, it's a quick test to see if it's working or not working. That's why we use it. What I'm going to say here about encoding mysteries is it's kind of like a Hollywood story. A good movie you go to see, they claim that it's the truth. I'm claiming that what I'm saying here is the truth. But as in all Hollywood movies, I could make certain liberties with that truth. And if you happen to have a different view of the world, if you know the real truth, or then I hope that you interfere and set the record straight. Don't let people here believe the Hollywood version, my version, if there is another one around. Which leads me to the fact that I hope that you take advantage of the situation we are in here. The people watching the video afterwards, they don't get the opportunity to interfere or ask any questions, but you can do if you want to. In this particular case, whatever you ask me about, I have a very simple answer. Because when it comes to encoding mysteries, the answer is UTF-8. It's very simple. So actually, whatever you're going to ask me today, I have a simple answer. What time it is? UTF-8. What's the shoe size of Bill Corey? UTF-8. Duh. When will LDC09 be released? Actually, I don't have that answer. That's hidden in the dark. So no, UTF isn't the answer for everything, but almost. The reason why we're here talking is because there are so many people in the world that do stuff without thinking. And it all started early on in the computer age, in the dark ages. It might have started here. This is a high-tech machine set up. It's a teleprinter set up. They are actually sending text on a long distance with an immediate receiving in the other end. Isn't it amazing? They can do that. It goes with the speed of light. Maybe it started here. This is the first computer claimed to be ENIAC. That could be the reason to why we're here. Or maybe this one. This is the first binary machine that used a binary computing system. And the problem with all these setups is that they were tremendously expensive. And memory was the most expensive part in these setups. So, in those days, a good programmer was the one who wrote code that took the smallest amount of memory ever possible. Then you did a good job. And having an input system to put characters in and out of the machine, that was a tremendous waste of memory. So you really wanted to make it as small as possible. So what they did in those days was that they looked at the keyboard and they said, what do we need? How little can we get by with? And we got A to Z, we got 0 to 9, we got some dots and exclamation marks and lots like what, 100 different characters. We need some ways to represent line feeds and some other control characters. So how many binary digits do we need to handle this? And they came up with this figure 7, because that gave them 127 different representations, and that took care of all that. That meant that they could use A to Z as capital letters or versions of that, and all the rest, and that was it. So around 1960 they came up with a standard for that and called it ASCII 7-bit. That gave them those 127 different versions of characters to use. But since they didn't think beyond their own nose, or actually maybe because they only had an issue of entering commands and getting out like trajectory calculations for missiles or whatever they used this stuff for, it wasn't word processing directly. They didn't care about the rest here. They simply neglected all the rest of the world, or any other need than to get trajectory calculations or weather forecasts, statistics. So since then, we've had this issue. How do we deal with this other stuff? The first solution was to stay with 7-bit ASCII. When we started to import computers to other countries than the United States, this problem immediately arose. Which one? Arose. Thank you. Put that into the memory bank. And the solution then was that they simply took out some characters. They said, well, Swedes don't need curly braces. We just replace curly braces with this peculiar looking character instead. So whenever you hit a curly brace, you get that. And they did the same in Denmark and Germany. Took out the most odd characters from the ASCII 7-bit set and replaced it with what's needed in that particular country. Which meant that you couldn't actually deal with two languages at the same time, of course. So eventually they found out that, well, maybe that was not such a good idea. We'll add a bit to the ASCII code and use 8-bit ASCII instead, because that gives us 256 different characters. Wow, that's a lot. That should please the world, right? Unfortunately, they did not think of to use the same 8-bit standard. So different operative systems had different implementations. And I believe that I once read that you had 76 different ways of encoding characters floating around. That's why we had all these issues with moving information from Macintosh to Unix to Windows and so forth to mainframe systems, from web to mail, etc. They all use different encoding systems, different interpretations of the 8-bit handling.